Hello everyone, my name is Winter, and today I wanted to talk a little bit about designing for machine learning driven features. These are drawn from my experience working at Kira Systems, and hopefully you'll find them helpful. So a little bit about myself, I'm a product designer. I founded and led the product design team at Kira Systems. You might be wondering who is Kira Systems. So at Kira Systems, we help lawyers and other professionals such as auditors um, review and make sense of really large amount of legal documents using machine learning. So it doesn't really sound that sexy at all, but here you go. So a little bit about machine learning, since that's sort of the technology we get to work with. So first of all, it's not magic. Um, it is a subfield of artificial intelligence, which is highly related to statistics and probability. And it's very good for tasks such as classifying things, predicting things, and clustering things. Um, so think about your like a lot of the products that you use every day, like Spotify and Amazon, Google. A lot of these things actually use different kind of algorithms to accomplish some of these tasks. Um, and it might be helpful to also know that mainly there are three different kinds actually, but to make things a bit simpler. So supervised machine learning is the kind of machine learning where you teach the system to understand certain things, whereas unsupervised machine learning algorithm is basically the machine just does things on its own, such as clustering, which I will talk about in a bit. So designing a machine learning driven product. So in the next 15 minutes or so, I'll talk about the lessons that I've learned, some of the challenges that we face designing such products, not only in the context of Kira, but also machine learning driven products at large. And then some of I call them suggestions, but it's really something that I personally find helpful. Um, so here we go, lessons. First and foremost is really what I've learned. If there's anything that you will remember from my rambling today, is remember this, right? The most important thing is really understand your user's mental model and match the interface to it. And like for those of you who are actually UX designers or product designers, this is nothing new or groundbreaking. Jacob Nielsen and Don Norman has been talking about this since the 90s, but I really want to emphasize how important it is. And the second thing is really adapt your interaction based on the kind of user tasks. What you'll find is that certain algorithms are better at certain tasks than others. So understanding what their goals are, what their tasks are, is really, and adapting your interface and interaction to it is really, really important. And in the end, establishing trust and allowing negotiation. So users need to be able to negotiate with your system. And then I'll use a case study to sort of illustrate those points. And this case study is when we designed something called the document clustering. So using an unsupervised machine learning algorithm to group similar documents together. You might be thinking, okay, how hard is that? Interestingly, so machine does its thing, it groups similar documents together, but what counts as similar document? There is, if you look at all the documents that it clusters, it's really, really hard to put a label or attributes on it. Is it the type of document? Is it the title? Is it the way it's formatted? It's none of these, is none of a simple or like a single thing. It's a combination of a lot of the things. So the design challenge that we face is, okay, how do we design the interface and experience such that users can actually find it useful? So in the beginning, obviously, when you think of a cluster, that is the first thing you think of, a kind of visualization where you have like dots or clusters. Um, and So the first thing, so we did a few rounds of user interviews and trying to sort of understand, okay, do they find it helpful? How do they see this thing? And then first thing we learn about users' mental model is consider this quote. Someone said, I don't know what the computer is looking at. I'm really hesitant to trust it, and I don't know how it's moving. And so what does this quote tell us? It tells us that users won't intuitively trust a black box algorithm. When you work with any sort of machine learning algorithm or whatever, as a designer or as someone who actually works on the algorithm, you're like, of course you will trust it, right? It's accurate or whatever. But for user, that's just not like trust is not their intuition. And the second thing we learned is illustrated in this quote. Someone said, there's got to be a punchy way to explain why something's an outlier. So when you group similar things together, there's ought to be a group where things are outliers that don't really belong to any of the groups. So what does this tell us? It basically tells us that when trust isn't there, people would want an explanation. And that's pretty intuitive, right? Like if you don't really trust someone, then whatever they do, you're like, there has to be a way to explain this. So then, okay, so you think that, so first of all, they wouldn't intuitively trust this algorithm and they want an explanation. And so as a designer or someone who is working on a system, you think, okay, they must want transparency. They want it to understand, right? But is it? Is it transparency that they want? So now let's take a detour and think about the Amazon recommendation system. So this is the kind of interface you see. This is a screenshot of my Amazon interface, and you can see that I buy a lot of design and comic books. So think about this for a while. Do you know how this works? Do you know how Amazon recommendation system works? So if I were to tell you that common recommender systems use techniques such as collaborative filtering or singular value decomposition, does that kind of explanation help you understand how it works? Maybe if you're a developer, it does. But was that how you thought it worked? And do you actually need to know exactly how it works to actually use it? And I'll probably venture to say, not really. So then why is it that when you look at this interface, you don't really know how exactly the technical details of how it works, but you are able to intuitively understand how it works? In your mind, it's like, if I like this book, I'll like that book. If I bought this kind of books, I'll like, they'll recommend. So this is exactly my point of they were able to understand your mental model of how certain things work and match their interface to it. So now let's go back to our question about whether it is transparency that we should provide. I would propose it is not transparency, it is interpretability. It is the ability that people should have to interpret, to understand your interface by providing users something that they're really, really familiar with. So familiarity. Because this kind of familiarity, they were able to interpret the interface and they were able to predict what's going to happen. So giving them predictability. And ultimately, that's how you build trust. And the next thing I wanted to talk about is adapting the interaction based on tasks. So throughout our interview with our users, which are mostly transaction lawyers who work on merger and acquisition sort of deals, we really got a chance to understand, what their goals are, what their motivations are, and what their tasks are based on their goals and motivations. So ultimately, for a merger and acquisition deal, the most important thing is being able to identify risks in such transactions. And it's a highly stressful situation. they usually are given a really short period of time, and they need to go through thousands of documents and looking for those like needle in a haystack kind of thing. So given those kind of context, we understood that efficiency is their priority. That is the number one thing, which led us to actually realize document clustering, the thing that I showed you, is the most helpful when it's for a project management type of task. And in particular, people really, where it shines is that people want to assign similar documents to the same reviewer to review, because that would really increase the kind of efficiency. So under, understanding this kind of background would allow us to transform something like this into ultimately something like that, which looks completely different and not as, I guess, innovative or sexy as other things. But here we go. So what we learned here is, sometimes good enough is good enough. Um, and as you have trust, so last thing, that kind of leads to the last point, which is trust and negotiation. Once trust is established, users are actually more likely to tolerate inaccuracy and more likely to negotiate with the system, even though intuitively you would think, accuracy is probably the most important thing. If they see something that is not accurate, they'll probably likely to abandon it. But the key here is, once you give something that people can interpret and they can understand, once that trust is built, they could actually tolerate a little bit of inaccuracy and spending some time to sort of changing things, negotiating with things. Which also means the design implication is that allowing that kind of user control is really, really important. So give them a way to actually negotiate with the system. And next thing I want to talk about are some of the challenges faced in designing a really sort of black box-ish and fuzzy algorithms. And which is really the biggest thing is the imperfection of the results you might get. None of the algorithms is perfect. There's always a little bit of inaccuracy that is kind of built into it. And because of this kind of imperfection, think about how many are here use Spotify, right? Whenever you get a music recommendation, you will never get the exact thing that you want. Like whatever recommendation you get, there's always something you're like, I'm not sure why I get this, right? So how do, as designers dealing with these kind of things, how do you deal with imperfections? So especially think about when there are imperfections, how do you make things interpretable? How do you make things predictable in a way? And also, how much negotiation is enough? You don't probably want people to do a lot of manual work to actually correct you. So finding that balance. So I'm tossing these challenges to you to think about. I don't have an answer. And lastly, some of the things I found really, really helpful in designing for things like this is really basic things. Know your design heuristics. If you know Nielsen's design heuristics, these are some of the things I just talked about. It really reinforces some of the heuristics that he established a very, very long time ago. Things like giving feedback, giving control, things like matching their mental models. All of these kind of things are already described in these heuristics. And the importance of doing user research. There are so many ways that we can do research. You can do interviews. There are ethnographical kind of research. You could do card sorting. There's mix and match your research techniques in order to unpack their mental models. And one of the things that's I find to be really particular for kind of machine learning algorithm is that you have to really test with real data as early as you can. There are because of that imperfection we just talked about, there's a difference between testing a concept, which means like you do paper prototyping or whatever. Um, but if the results, like the effectiveness of your design, really comes across from the actual results. So if you do end up working with something like this, I really encourage you to try to test with real data as soon as you can. And that brings me to the next point, which is really collaborate with data scientists who work on these algorithms, become their best friends and collaborate with them. And this is, I guess, one of the best ways you could try to test with real data, right? Um, and then bonus, if you wanted to learn some machine learning basics, that would be really helpful. That would really kind of help you. We still talk about designers and developers. Designers being able to talk in development terms and building that bridge to work with them, and it's the same, right? Like the more you could actually understand these technical things, the better you can communicate with your data scientists. Um, and lastly, there are a lot of academic papers out there. A lot of people in the academics field are doing this kind of research to try to understand the design implications um, of designing, information retrieval systems and recommendation systems, such things like this. So if you want it, Google Scholar is a really, really great place to look for academic papers. Um, for the machine learning basics, Coursera, there are a lot of courses, really, really good machine learning courses on Coursera. You can check them out. So yeah, so that's what I have to say today.
Question?
Oh, question. Yes.
I really like your example of like the Amazon recommendation system. But from my understanding, Amazon uses the mechanical turk, which is like people, like real live people who get like 2 cents per photo that they're like, oh, is this a match? Like, does this coffee maker, is this coffee maker related to that coffee maker? Or whatever, using that a recommended product, like recommending this person. So there is still like a big human element to it. Is that just like we're not there yet in terms of machine learning? We still need like human input.
It's Yes. So the question is, the Amazon recommendation system still uses a lot of people, but using mechanical turks, which is kind of a crowdsourcing platform where people get paid to do certain tasks, right? Um, that's actually interesting. I actually didn't know that. But it's really interesting to think in terms of what the algorithm is doing is really not really that different from how we think about when you recommend people things based on certain things. There is no you might look at a variety of different, they call them features in machine learning, right? Like it could be the type of books, it could be the author, it could be what else could it? There's so many kind of different features that people are looking at in terms of recommending things, and that's ultimately what the algorithm is learning by combining all of these features together.
Right. So it's getting better and better, but we're like not to the point where like we can exclude from.
Yeah, I don't think you could ever have a perfect, as I said, I don't think you'll ever have a perfect algorithm. They could, I mean, they probably could exclude the people part, but it's just a different way of thinking about these things, I guess. Yeah. Yes.
So I actually think that Amazon has it easy because they have all the sales data, and like person A bought these 2 books, and that happens 10,000, 100,000 times, and so they can say, they can present that to you as a carrot, to get you to buy the second book or whatever, right?
Yeah.
So the recommendation engine really is just big data and just some, rudimentary clustering.
Yeah.
But I'm looking at what you're doing here, and I'm going, Jesus, that data is so nebulous. Like, I mean, like, how do you even begin to categorize the documents in the first place in order to be able to say that this A is related to B?
Yeah, that's so. The question is, for commercial systems such as Amazon, they have enough a big enough data that do training this kind of algorithms is easy. Yeah, and I think that's a really good point. A lot of you might know that in terms of algorithms, data is crucial, and it's the more data you have, the better. I wouldn't say that. The more and better data you have, right? Like it's also about the kind of training data you feed it. Sometimes it depends on that kind of match between the data that you feed it and the sort of tasks this algorithm is like designed to do in a way.
But
So
a
yeah.
starting point would be parsing these documents and somehow characterizing, giving the document properties that you can use to then on the next level start to match them with other documents. And it just totally goes.
Yeah, actually, the clustering thing that we use is actually an unsupervised algorithm, so there was actually no training per se. We do have other
So
features
it
that
just looks
relies
for
on,
patterns and
but in a way, it sort of takes the documents, turns them into vectors, and then compare the vectors. Yeah. So it's a little different than having training data and getting the results. Yeah. Any other questions? Yes. Yeah. Yeah. So the question is, do we look at different, I guess, user personas and what they like, what their tasks and what their goals are, and contextualize the interface to it? That would ultimately be the goal. We're not there yet, but in this particular feature, the way we did the testing is actually we did three major phases of research and design. So like the first version and last version look completely different, work completely differently, and we interviewed about 27 people, did a combination of interview and testing, and the last phase of the research, what we did is, as you're building a product, you obviously one of the things like prioritize um, this thing, and so our understanding is, as I said, it's a really good feature for project management so that project managers could assign similar documents to the same reviewer. So we basically locked down to this particular use case and said, we're gonna just make sure we optimize this particular use case. And so in the last round, one of our hypotheses was actually um, the way people interact with this and the way people how much they trust such a thing is probably related to their role. For example, if you're a reviewer, maybe you care about accuracy a little more. If you're a project manager, you're like, I'm just gonna like dump these documents to reviewers and let them figure out kind of thing. So we did test this feature with I think we probably interviewed about 8 people, and 3 of them were not project managers; they're reviewers, and the rest are project managers. And this particular hypothesis, wasn't either accepted or rejected, but we did find among the project managers that we tested, the results was really positive. So yeah, so definitely, I think if resource limitation or whatever, you can't do all of these parallel usages all together, at least make sure that you optimize for one thing and really understand that use case. Yeah. Yes.
Um, so when I think of like machine learning and especially the legal profession,
Mm-hmm.
uh, I just see like wrongful conviction, and and this is what's kind of like flashing in my head. And I was even reading that they're automating divorces now. Hello, but um, have you come across whether it be something that you saw yourself firsthand, or like whether some cases out there where machine learning and legal has gone like drastically wrong?
In Kira, we don't really deal with conviction, that kind of thing. So I haven't come across anything from the use case that I directly am involved in. But what you said is actually a really, really huge debate currently in terms of justice and technology and that kind of thing, right? Like there was a thing called Campus. I don't know if you heard. It's basically a justice system where they would predict the likelihood or probability of some repeat offender. And there's a book called The Weapons of Mass Destruction, if you're interested in this kind of thing. Where it talks about how like it reinforces that kind of racial profile, but I guess mass destruction. Yeah. But the thing is, as I said, it like the algorithm, a lot of it is based on the kind of data you feed it, right? So it's if the person who is kind of making these kind of judgment think that it really depends on the kind of data that you feed it. I'm again not a machine learning expert, so I probably should not say a lot of the technical things. But within our field, that is a really good point. So lawyers are really, really skeptical by definition. So a lot of our users, and that's why I really, when I was thinking through these things, trust is a huge deal for our users. Like for music recommendation, for example, it's important. Like people study these kind of things, but like it's not, you're not gonna die if you're getting a recommendation that is not perfect, right? Whereas in some of these cases that we deal with, merger and acquisition kind of transaction of big companies buying another company, if you miss something or you misinterpret something, like you're gonna face, a lot. Like the stake is really, really high. So this is where like I think it's a continuous kind of exploration where we try to find a really good balance between the human and the machine, like sort of working together, right? A lot of what we do is really trying to take that sort of manual, repetitive process out of their way so that they can focus on the important things. Yeah. Does that answer the question?
Thank you, Winter.
Yeah. Thanks.